Okay, so Chapter 3 test. Test is on Friday. Hardest test we take. Let's make sure we do well. This is the Chapter number 3, pre-test number 2. We're going to go over some questions real quick. I'm going to go through fairly quickly. Go back and re-watch it if you need some help. First one, it says, find the potential rational zeros of the polynomial P's and Q's. Remember, P is the last number, so in this case, P is 8. And the factors of 8, 4, 2, and 1. Q is equal to 1. So my P's over Q is plus or minus all of the P's. So 1 over 1 is 1. 2 over 1 is 2. 4 over 1 is 4. 8 over 1 is 8. Done. Okay, so in problem number 2, same questions going on here. Listen, P's and Q's. P is the last thing. Q is the first thing. So in this case, my P is 24. So I wrote down 24 and the factors of it. 24 and 1, 12 and 2, 8 and 3, 6 and 4. Then my Q, that's the first number, so my Q is 2. Factors of 2 are 2 and 1. When I make my list, I take all of my P's over all of my Q's. So I went 1. I started off here with 1 over 1, which got me 1. And I did 1 over 2, 1/2. 2 over 1 is 2. 2 over 2 is 1, so I didn't list it again. 3 over 1 is 3. 3 over 2 is 3/2. 4 over 1, 4 over 2, don't need it. 6 over 1, 6 over 2, don't need it, and so on. That's where I got my list. Question number 3. Easiest question on the test. It says degree is 4. That means how many answers are there going to be? It means there's going to be 4. Here's one answer, 3 minus 4i. Here's another answer, I. Remember, they always come in pairs, so if 3 minus 4i is an answer, so is 3 plus 4i. If I is an answer, so is negative I. Done. Imaginary numbers always come in pairs with their conjugate. Question 4. Same thing. You can handle that one. All you're doing is writing the conjugate of that. Negative 3 minus 2i. Done. Don't do anything else besides that. Question number 5 says write the polynomial with a degree of 3. That just means you're going to have 3 factors. That has the following. Zeros on this first one. The zeros are 3 and 2 plus I. Well, if 2 plus I is a factor, or a 0, so it's, not 3. Nope, can't erase that. Alright, hang on one second. Not 3. My thing's being stupid. 2 minus I is a root. Okay, so I write my factors. X minus in parentheses, so it's x minus 3, x minus 2 plus I, x minus 2 minus I. I'm going to put together the 2 imaginary ones first. So remember, we're using sums and products. So it's always x squared. Then it's the sum step. So it's negative 2 plus negative 2 is negative 4. I minus I would cancel, so it reminds us to put an x. Then we're doing the product step. We're multiplying. So the product step is negative 2 times negative 2. That'd be positive 4. And I times negative I would be negative I squared. When I simplify, it's going to give me x squared minus 4x. 4 minus I squared is like 4 minus negative 1, so that's going to be 5. There's that. Now all I need to do is multiply in the third. X minus 3. So I FOILed the 2 things. I got this left over. Check your math. When I combine like terms, I get x cubed. I've got negative 4x squared and negative 3x squared. So negative 7x squared plus 17x minus 15. That is my polynomial. I'm going to do the same thing on the next one. Just hit pause. I'm going to show you the whole work. So I did sums and products. First of all, I wrote my 3 factors. X plus 1, x minus 5 minus 2i, and x minus 5 plus 2i. I did sums and products. When I did that, I got x squared minus 10x plus 29. Then I would multiply in my x plus 1 left over. So I did distributing with the x plus 1, my final answer was x cubed minus 9x squared plus 19x plus 29. On number 7, we're trying to find all of the asymptotes. First, I set the denominator equal to 0. I factored out an x. When I solve for the denominator, that will get me my vertical asymptote. So my vertical asymptotes are at x is equal to 0 and 2. Hopefully you got that. We've done that one quite a few times. The second thing we need to do is look at our chart to determine horizontal and oblique asymptotes. On top, the degree is 3 because it's x cubed. On bottom, the degree is 2 because it's x squared. So my numerator is greater than my denominator by 1. That means oblique. I'm going to have to do long division on this one. So I set it up down here. I'm doing long division. Remember, we just care about y equals mx plus b. So I go x squared times what gets me x cubed. X, that gets me x cubed. X times negative 2x is negative 2x squared. I'm combining, so I change the signs. Cancel 2x squared. Bring down the 4x. Then I ask myself, x squared times what gets me 2x squared? The answer is positive 2. That is my answer. Y is equal to x plus 2. I have an oblique asymptote at y equals x plus 2. There's my answer to the second one. 7th one. On number 8, I'm going to set the denominator equal to 0. So my answer is x is equal to negative 4 for vertical. My degree in the numerator is 1. My degree in the denominator is 1. So since my numerator is equal to my denominator, I'm looking at the leading coefficients to determine horizontal asymptote. So I have a horizontal asymptote at y is equal to 3 over 1. So my answer is y is equal to 3. On number 9, I set x squared plus 4 equal to 0. I'm going to subtract 4. X squared is equal to negative 4. When I take the square root of that, it's square root of a negative, so it's imaginary. So vertical asymptote at x is equal to, we don't have a vertical asymptote there because it's imaginary. Okay, then we do degree of the numerator. Degree of the numerator is 1. The degree of the denominator is 2. So since my numerator is less than my denominator, horizontal asymptote at y equals 0. On number 10, set the denominator equal to 0. It's x squared plus 4x minus 21. So I decided I needed to factor in order to solve this one. So I thought to myself, x times what gets me 21? Or what multiplies get me 21? So it's 7 and 3. To get 4, it's got to be plus 7 and minus 3. So my x is equal to negative 7 and positive 3. Then I look at degrees. The degree of my numerator is 5. The degree of my denominator is 2. Since my numerator is greater than my denominator by more than 1, I have no horizontal asymptote or oblique asymptote. We're going to go through this last section really quick. It says list the real zeros and their multiplicity. Determine if it crosses or touches. So we're setting each thing, since I already factored, we set each thing equal to 0 and we solve. 2x equal to 0, x is 0, the multiplicity is a 1, so it's cross. X minus 6 is equal to 0, so x is 6. The multiplicity is 3. It's an odd multiplicity, so it's cross. The last one is x plus 2, so it's x is negative 2. It's 2, touch. On number 12, I set each part equal to 0. I get 4 is equal to 0. There's no x involved, so I really don't care about it. It's not going to be an x-intercept because it does not have x. When I set x minus 2 equal to 0, x is 2. The number on the outside of the parentheses is a 1, so it's going to be a cross. X plus 3 squared, so x is equal to negative 3. It's a 2, so it's touch. And the last one, I set x squared minus 16 equal to 0. So x squared is going to be equal to positive 16. When I take the square root, x is going to be plus or minus 4. Since the number on the outside of the parenthesis is a 1, it is a cross. On my last one, x squared plus 3x minus 10, set it equal to 0. I'm going to factor x plus 5 and x minus 2. So my answer is x is equal to negative 5 and positive 2. The number on the outside is a 1, so it's crossed as well. Go back and rewatch what you need to rewatch. Hardest test on Friday. Get a good grade.